Hey everyone, so today it's time for some more interesting nitrogen chemistry, which I think I've been doing a lot of lately. Anyways, whipping out some urea and some sulfur for a change, and some other things of course, because today we're gonna try and make sodium thiocyanate. Now, the way we're going to do this, and by we, I of course mean myself, like there's no one else here. The way I'm going to do this is by reacting urea and sodium carbonate along with a bit of charcoal, but I don't have that here right now, and that'll give us sodium cyanide, which is horrendously toxic, so be careful with that and don't eat the chems. And then we're going to react that with our sulfur to make thiocyanate. Now, as I said, cyanide is fucking toxic, and if you were to screw up while working with cyanide, you could very well die. Like, it's some poisonous shit, and if you, like, for example, accidentally add an acid, it'll gas you with NaCN, which is not fun. Yeah, if something happens, it's totally your fault. I warned you, you know? Yeah, sure. This is fucking scary shit. So anyways, as I said, first step is to react these two and some carbon. Alright, time to open it up and see what we actually got in here. Yeah, here it is. Notice I'm actually wearing gloves here, which is rare, but yeah, this is some poisonous shit. Although I could just wash it off. Anyways, before someone starts complaining again about me not wearing gloves around a thing as toxic as cyanide, here you go. Now be quiet and shut the fuck up and fucking get out of my comment section. Yeah, either way, here it is. Not very spectacular. It's just sort of melted to the thing. Guess I'll have to dissolve this out. Righty, here goes some water. Oh. Yep. It should dissolve fairly rapidly because, well, cyanide is very soluble. Oh yeah, think it's starting to... okay, no, it's not. this might take a while to fully dissolve. Also, yeah, look, it's still black from all the carbon in there. I've transferred all of my intermediate solution into this 500 milliliter flask. Next up, I'm gonna add about 30 grams of sulfur, which is half of what I theoretically need, roughly. And then I'm gonna reflux it, and if it's at some point all used up, I'm gonna add another 30 grams. And assuming that reaction goes to completion, we should have basically pure thiocyanate in here. Well, not pure, along with some impurities that are already in there. Alright, so after some like 3 hours of reflux spread over like 4 days or something, it's turned into this dark brown solution, and it reeks of polysulfides, and there's still cyanide in it because I did some tests with like acidifying a bit of this and adding some iron 2 and 3 salts, and it produced a sort of a blue precipitate of this pigment, Prussian blue, which is a positive test for cyanide. So it's not all converted yet, and I wondered what it was going on here. Like, why is it building up the polysulfide, and why is there still cyanide? Why is it not reacting? So at this point, this doesn't really want to be boiled down any further because it just starts like vigorously bumping and trying to kill me probably. The good thing is I can't detect a lot of cyanide in here at this point. And instead, if I do the iron test on it, I just get a red coloration, which is from the thiocyanate, which is good. The stuff that's crystallized out, or rather precipitated out here, is some grey mess of mostly sodium carbonate and maybe a bit of cyanide. Who knows? It's gonna get rid of that. Either way, this is still full of sulfide. You can kind of see it's doing its best there to precipitate some sulfur already. So I'm gonna acidify this, of course, in a very well ventilated area because it's gonna produce hydrogen sulfide. And I'm just gonna acidify this using some formic acid. Formic acid because it's volatile, I have it, and it's not too strong of an acid, and that should be just right, I think. Okay, any acid would really work here, I think. Yeah, just so all that sulfide kind of gets broken down. And maybe some cyanide, which is not healthy to breathe, but hey, sure, I'll get it done.
Then filter, wash with a little ethanol and dry thoroughly on the pump.
So after literally the 4th time of boiling it down, look at it, we've finally got some crystals. It's very hygroscopic, so I had to put it in this little jar thing. Yeah, that means it's almost definitely our product thiocyanate. Not very much of it, but I've still got quite a bit more water to boil off, I think. This stuff smells like sulfury garlic something. It's terrible. So yeah, gotta concentrate that more, but hey, this is a start at least. Okay, so after all that, I'm left with these two jars here. This right here is from the recryst from ethanol. I also ended up boiling down that solvent a little so I could crystallize out some more, and after that I had a bunch of like very wet ethanol still left that wouldn't precipitate anymore, and boiling it down also didn't really work, so I just boiled it to dryness. That's this right here. It's a lot less pure and it's light brown, still reeks of garlic or whatever it is, sort of a sulfury kind of garlic smell. Either way, it's still thiocyanate and I think I can still use it. The amounts I have here are like 31 point something grams in here and another 15 grams in here. In total that's like what, 46 point something, which equates to a 29% yield based on starting sodium carbonate. Yeah, that is amazing. Not even a 30% yield. That is absolutely amazing and I'm fucking pleased with it. Alright, so at this point I forgot to record like an end bit, and it's already been like 2 months since then, so I don't know what I still had to say really, so yeah, I don't know, have a good one and see you next time.